section is finding the zeros of a polynomial function. So we want to find the zeros just by given 1 0, can we find all the others? And we've kind of did this before, but we necessarily haven't had complex numbers in there. So here's our function, x to the fourth minus 3x cubed plus 18x squared minus 22x plus 12, and we're given 1 0 is 1 minus I. So we're kind of going to do it just like we did before with synthetic division. And we set it up, make sure everything is accounted for, list our coefficients, make sure we have all our numbers accounted for. There's something must be missed. No, we're good. 4, 3, 2, 1, 0. Okay, we're good. Right, we should have 5 numbers listed, which we do. 0 in the second row. What goes in the box is our 0, which is 1 minus I. This is where it gets a little more complicated because I have to multiply by a binomial. So 1 plus 0 is 1, multiplied by the binomial is 1 minus I. Now when I'm adding here, that's another complication. I can only add the real parts, right? Because negative 7 is a real part, and so is 1. So we get negative 6 minus I. Now here's where we have to multiply binomial times binomial. And so we should get a trinomial. Actually, we'll only get a binomial because we're going to take eventually I times I, which is I squared, and that becomes negative 1. Okay, so 1 times negative 6 is negative 6. 1 times negative I is negative I. Negative 6 times a negative I is a positive 6I. And then a negative I times a negative I is a positive I squared. I squared turns to negative 1. And negative 1 and negative 6 is negative 7. And then minus I plus 6I is a positive 5I. Right? Just because it says minus I doesn't mean I'm canceling out that I. Right? I'm taking 6 and minusing 1, so I get 5. So that's what's going to go up here is minus 7 plus 5I. These are the only parts we can add, so we get 11 plus 5I. Now we're going to multiply again here. So we have another binomial times binomial. We get 11 plus 5I minus 11I, and then minus 5I squared, so that turns that to positive 5, so we get 16, and then minus 6I, because 5 minus 11 is negative 6. And so that goes up here. All right, now we add our real parts, so that is 6, negative 6, negative 6 minus 6I. We multiply that together. So let's scoot down a little bit. So we're going to multiply those two binomials. So we get negative 6 minus 6I plus 6I plus 6I squared. And I squared turns that to negative, so that's a negative 6, and a negative 6, that's a negative 12. And these middles are going to cancel out, right? Minus 6 plus 6 is 0, so we just get negative 12. Oh, that's really nice, right? Look how it worked out. 12 minus 12 is 0. So this is a 0, which we knew, right? It says given that 1 minus I is a 0. Okay, so now we can erase all this scratch work here. And now what we can do is we can go ahead and start doing it again, because we know if 1 minus I is a solution, that means that, let me do it differently. That means that 1 plus I, its conjugate, will be a solution. So now I can use these new coefficients, 1, negative 6, negative I, 11 plus 5I, and negative 6 minus 6I as my new coefficients. And then the number that I'm going to throw in is going to be 1 plus I, because I know it's a conjugate, so I know that is also a solution. Okay, so again, 1 plus 0 is 1. Now I multiply it by 1 plus I. That is a 1 plus I. Now here I can go ahead and add my real numbers, which is negative 6 plus 1 is a negative 5. And I can add my complex numbers. Negative I plus I is 0, so I just get negative 5. Now I multiply that, and I get negative 5. And then I also got to times it by the I, which is negative 5I. My real numbers is 6, and then 5I minus 5I, 0I. So these i's are getting rid of. That's kind of really nice. And then 6 times 1 is 6. We know this should be 0, right? So here's a little test to prove that kind of conjugates are solutions. It's not really a proof because you need for all of them, but that's okay. All right, onward. And then plus 6i. Look, everything cancels out, of course, and we get 0 here. All right, so now we have these coefficients now, 1, -5, and 6. Now what is the variable? What's going to be the variable, and what's its degree going to be? The variable from the beginning was x, so we use that same variable. So we have 1x minus 5x plus 6. Now what is the exponents on all these? Well, we started with a fourth. So this first coefficient right here at this line would be to the third, and this line would be to the second. So this is going to be squared, this is a 1, and this would be x to the 0, which we don't write because x to the 0 is 1. And we don't usually write a 1 as an exponent either. Okay, so there's our quadratic. Can we factor that quadratic? Sure, we can try. If not, we can do quadratic formula, right? So what are the factors of 6 that add up to -5? That'd be x minus 2, and then x minus 3, right? Because minus 2 times minus 3 is 6, and then minus 2 plus minus 3 is minus 5. So those are our two factors. So we have 0 so far. Our zeros are 1 minus I, and then we have its conjugate 1 plus I, and then we have 2, because 2 minus 2 would be 0, and then we have 3, because 3 minus 3 would be 0. So those are all our answers there. Okay, so now you can go to page homework, page 316, and go ahead and try number 31. Okay, so here I'm going to go ahead and do number 31. So again, list your coefficients. 1, -7, 17, and -15. They're all accounted for, and then what's going to go in the box is one of our solutions, which they give us is 2 minus I. And we'll go ahead and run that through. This is probably the more complicated part because you're going to get a binomial times binomial. So we get 2 minus I. We can only add real numbers here. So we get minus 5 minus I. Multiply these. So here we're going to have to do some scratch work. We get -10 minus 2I minus I. Ooh, why did I put a negative here? Oh, that's right. Why did I do that? Maybe I didn't put that dot. That's an I. Okay, sorry. Sidetracked. Okay. And then -I, and then a positive I squared, which is -1, so that means -11 minus 3I. So -11 minus 3I. 17 plus a -11 is 6. So we get 6 minus 3I. We're going to multiply those, so we get 12 minus 6I minus 6I, and then plus 3I squared, which just comes -3. -3 plus 12 is 9, and -6I is -12I. Oops. One of those is probably, let me check. Okay, sorry, we need to go back right here. I took this 2 and multiplied it by -5, but then when I took the -1, I actually multiplied it by this one instead of -5. So this should be minus 5I. So that's minus 7I. So this should be minus 7I. So that's minus 7I. This is minus 7I. So then when we multiply, we still get 12. We get -14, because eventually these will cancel out. So 12, 2 times -7 is -14I, and then I times 6 is -6I, and I times -7. Okay, so sometimes you have to take it apart here, and this, oh man, you guys are going to be mad at me, right? So a negative, which I tell everybody all the time, right? A negative times a negative is a positive. Well, I did a negative times a negative is a negative. So a negative times a negative is actually a positive, so I get positive 5i, and then minus 2i would be 3i. Oh man. So this is a negative 11 plus 3i. So this is a plus 3i. Now stuff is going to cancel out. Let's actually write it like this times the binomial. 6 plus 3i. So 2 times 6 is 12. 2 times 3i is a 6i. And negative I times 6 is a negative 6i. Look at that. Now the middle cancels out. Negative I times a positive 3i is a negative 3i squared. Negative 3i squared is a positive 3, and 3 and 12 is 15. The middle cancels out. Hey, 15. Whoa, geez. I'm really actually talking sarcastically because I'm making fun of myself, really, not anyone else. Okay, so that's how you do that, right? So we got rid of that one. So we already knew that should have been 0. That's why I had to come back through time and time again to prove that it was 0. Okay, so now I have my true coefficients of my next line. So 1, negative 5 minus I, and a 6 plus 3i are my new coefficients. What's going to go in the box here is the conjugate of the one that I put in originally. So it's 2 plus I. Okay, and then we put 0 in, and now I'm going to really kind of make sure that I multiply my binomials, which I shouldn't have any binomials anymore, because we get 2 plus I. The i's are going to cancel out, of course, so we get negative 3, and we get negative 6, and then minus 3i, so the i's cancel out, the 6 cancel out, those are gone, so we're left with just those coefficients, and we started with, sorry, went too far, started with a cubed, so that became squared, so this is just x minus 3, so that means our answers are x equals 2 minus I, 2 plus I, and then x minus 3, do the opposite, is positive 3. So those are all my solutions for that. Wow, I really messed that one up. So hopefully you stayed with me. Or maybe you did it right in the first place, and you're asking, why the heck did you get that wrong? A negative times a negative is always a positive.